Hi and welcome to the next basic Blofeld tutorial. In the last video we saw the modulation matrix, which is here when this LED is selected and you go into the patch parameters, and we saw that every modulation slot has a source, a destination and an amount. And at the end of this list of 16 modulation slots, you have the modifiers, which are the topic in this video. So this page looks very similar to the modulation pages here, but modifiers are a bit different. Again, each modifier has two pages. On the first page you can select source A and source B, and on the second page you can select the operation and change the value of the constant value source. Okay, so I already said we have two source lists. That's a bit strange. A modifier is a special thing which takes two modulation sources, combines them, and is creating a new modulation source which can be used here in the modulation slots as the new source. Okay, so you have the same source lists as in the modulation slots, like LFO1, envelope generators, key track, and so on. And of course you can take the result of a modification and use it as a new source in a new modifier. So you can take, for instance, LFO1 and LFO2 using some kind of function which you can define here in the middle part, and then it's creating a new modulation source. The operations can be defined on the second page. You have an addition, so it's taking this value plus this value, and then modifier 1 is the result of this operation. Same with minus, multiplication, a logical AND operator, a logical OR operator, XOR. It's taking the maximum value of both and the minimum value of both. And a special thing is this constant here, which means when you select constant as the second source, you can define a constant value. So in this case here, it's taking LFO1 plus 14, and this is the result. So you are adding a offset to LFO1 in this case here. It's not very easy to understand what the operations do. That's why I wrote a little software, quick and dirty, to show you the behavior of these modifications, and this is easier for you to understand than as if I would explain it here somehow. So let's have a look on the software. Okay, so this is the software I wrote just for you. In the middle of the screen, I hope you can see it, there's a green line which indicates the value 0. If you can't see it, you have to make your video a bit bigger, I think. And this area here, which is black, is something like a like the screen of an oscilloscope. And the line here is a modulation value. So in this case it's a sawtooth. And here on the top I can choose different configurations. For instance, different modulation sources like sawtooth, sine, triangle, pulse, sample and hold, random values like the ones we have in our LFOs. I also implemented an ADSR and a constant value. With this knob here I can change the speed of the modulation, and I can show or hide the original value of the source. So I have 4 sources here, which means I can define up to 3 modifiers. Here we have the different modification operators, and here in the right corner we have different simulation rules. In this case here I'm showing source 1 directly, but also possible are, for instance, combining source 1 and source 2 with a modification, source 1 with source 1, taking source 1, modifying it with source 2, then taking the results and combining it with source 3, and also source 1 and source 2 combined with the result of source 3 with source 4, and last but not least source 1 with source 2, then modified with source 3 and modified with source 4. So I'm simulating here up to 3 modification slots, but remember the Blofeld has up to 4, so it makes the things even more with even more possibilities and more complicated modifications than I'm showing here. Okay? Okay, so let's start with the modulators as they are in the Blofeld. As you can see, there are steps in the lines here. When I'm choosing it like this, you can see that the lines are not lines anymore, they are like a bunch of dots. And if I make it like this, you can see the steps here. This is because the Blofeld is a digital synthesizer, which means you have time quantization in this direction, which is causing these steps to be a constant value in a very small part here. And we have also value quantization in this direction, which is causing the steps here. Okay? And it's important to understand that it's a digital synthesizer because some of these modifier operations here are digital modifiers, AND, OR, and XOR. Okay, so maybe I'm going to show you something I did for a different video. I have to find it, sorry. Okay. Yes, this one. So, in the video about fixed panorama for different key values, I explained the modifiers like this. This is just the AND operator. So every value in the Blofeld is like this when we trying to translate it to bits. Yeah. So this is the number 0 and this is number 1. And the logical operators are bitwise operators, which means they're combining bits in the same position for both values, and then they are deciding which bit will be in the result value. So the AND operator is like this: 0 and 1 is 0, 1 and 1 is 1, and 1 and 0 is 0, and 0 and 0 is also 0. Okay? So when we have more complicated numbers like 57, this is the resulting bit sequence. And as you can see here in the middle part, if you take two numbers like 57 and 54 and applying the AND operator to them, you can get very different results like this one. So here only these two positions have ones in both numbers, which means that only these two positions will have ones in the resulting number. Okay? I'm not quite sure if it's important to understand this, but I just wanted to show you how binary or logical operators basically work. But of course you can just applying them without knowing how they work and just enjoying the results. Okay? It's up to you. Okay, so back to our modulation sources. Maybe you are a bit confused because there are no lines here, making this sawtooth looking a bit strange. But this is how digital sawtooths work. You increase the value and then you have a direct jump to the lowest value again and going up again. So there is no connection here. It's increasing the value and then jumping directly to the lowest value. Same thing with pulse, for instance. You have one value, go to the lowest value, go to the highest value, and so on. This is how the values actually look like. Okay, so sine wave looks more normal to us because there are no jumps. Triangle as you know it. Sample and hold, again with jumps. And random value like this. So these are the normal LFO values as you know them. This is how I implemented the ADSR, just to show an example, and a constant value, positive and negative. Okay, now to the interesting part. Let's take a sine wave. and let's combine it with a second source. Now I'm using the modifier, yeah? So I'm taking the sine wave, modifier 1 is plus, and I'm adding a constant value, which is in this case negative, but I can also take a positive, and this is the result. This would be the resulting signal of modifier 1. Of course, I can also take a second sine wave, and the important part here is that when you reach the maximum value, which is possible, and you're still adding a value, it's not changing anymore, so it's just keeping the maximum value. And the same effect with negative values. So you can get very complicated, very complex modulation sources by combining two existing sources. Or like this. This looks very chaotic. Yeah, you can see the original value here in blue and the other original value in red, and the result is white here. But we have also other operators like minus. And of course we can also choose the multiplication, but it's important to understand that a multiplication is like a multiplication of two values between -1 and +1. So we have the original sine wave here and the constant value, and remember the white wave is the result of modifier 1. So with constant value to 0, we have also the result 0. With a negative constant value, we get the inverted sine wave. It's important to understand that the result can only be as big as the input and not bigger. So now when I choose as a constant value plus 63 in the Blofeld, I'm not getting 63 times the original sine wave. I'm getting again the original one, because 63 as a constant value is like a multiplication with 1. And when I choose 31 as a constant value, I'm getting just half of the original sine wave. Okay? And of course we can also multiplicate more interesting sources, like two LFOs with sine waves, which is this result. And you can get very vivid, very interesting sounds by choosing these modifiers, because they seem to repeat very just in very long distances. Okay, now let's have a look on maximum and minimum values. Again, I'm choosing the constant as a source and a sine wave as a source. And as you can see here with the maximum operator, I'm only getting the maximum of both values. So it's comparing for every time slot both values, the value of my sine wave and the value of my constant, and it's deciding to use the bigger value of both. And this is the result. The minimum is the opposite of that. It's comparing both sources, and it's deciding to output the lower value of both. Okay. And now for the most interesting part. The AND operator is hard to understand, so it's actually doing a bitwise AND operation on both sources, in this case sine wave and the constant value, yeah? So this is the sine wave, and as you can see here, it's hard to see the original sources. It's creating a complete new a signal, and it's very hard to predict what the output will be. AND operator is similar to that. For you, maybe important is that when you choose a value like 3 or 7 or 15, you can operate a quantization of your original source. So you can choose here as a constant value in the second slot 3, 7 or 15, and you can choose here sine or whatever, and you can get a quantized modulation. This can be very interesting, for instance, for the ADSR, by choosing these modulation sources, the OR operator, and applying this to the wavetable change. You can make a very rough jumping from one table to another, which sounds a bit like PPG or very old digital synthesizers, yeah? Okay. So this is the OR operator. And we also have another one like XOR, which is again creating another kind of result. And now you can take the modifiers and using them in a second modification, like this. Let's take a triangle and here a sawtooth, and I'm taking the maximum. And as you can see here, sometimes my first source is the maximum, sometimes my second source is the maximum. And sometimes my third source is the maximum. And if you use 3 modifiers and logical operators, you can get very crazy modifications. This is almost like noise. Okay, I could show you a lot of examples, because there are almost infinite numbers of combinations here with different sources, different modifiers and so on. But I think this would be too much for one video, so if you're interested in a special combination, or if something was still too complicated to understand, just write a comment, and maybe I'm doing another video about the modifiers at some point. So if you have more questions, just write a comment, and I think that's fine for this video now. I hope you enjoyed it anyway. Try it yourself, have fun, thanks for watching, and have a nice day.